Okay. All right, so let's look at assignment just one last time so I make sure you understand what's going on here. Remember, this precedence here, all your multiplication, division, remainder go first. So sum divided by 4, first. Then the max times lowest, second. Then your addition because it's the lowest. And the by far lowest thing that gets done is assignment. So before it assigns this number into the answer variable, then it's going to do all this stuff first. Assignment is always done last. Always. Okay? There's no option there. Right? Also, if you want to update a value, say you want to make count go up by 1, because that happens a lot. Let's say you're keeping a total of a cart value or something, like you're in a grocery store and you want to keep track. You in your head have like a total in your head. When you pick up a new item, you don't just look at its price and put it into your variable of your total. You want to update the value that you have in your head. Java needs the same thing to happen. So if you want to add a 1 to count, the first thing you need to do is you say count. Take whatever is in count right now. Whatever number, 0 or whatever, 22, whatever's in there. Add 1 to that. This gets done first. So it takes the old value of count, whatever it was assigned above it, and then adds 1 to it. And then since the assignment is done last, whatever number comes up here, then overwrites what is done in count. So now, whatever this adds up to, count will now equal and be that after this. Every time, okay? There's no exception to that rule, and that's how it'll always work, okay? All right, so let's take a look at converting data. Because sometimes what you want to do is you want to make data get bigger. Sometimes you want to make data get smaller. Okay, and that's done by data conversions. Okay, data can either get bigger or smaller depending on what you want to do. They call that widening and narrowing. All right, so sometimes you want a number to get more accessible. You want a number like 14 to become 14.0 so you can do some decimal stuff with it. You want to do that all the time. You want to change integers into doubles. You want to change doubles back to integers. So we want to do that with data conversion. There's 3 ways to do that. You can do that by casting, arithmetic promotion, or assignment conversion. All right. If you want to do assignment conversion, that's when you essentially assign, a decimal to another value or something like that. Generally speaking, assignment can only happen by widening. What do I mean by that? Let's look at an example here. Okay, let's go ahead and create one. All right, let's make a new file, and let's call this conversions. Okay. All right, so public class conversions, public static void main string args. Oh, got one too many parentheses, my bad. All right, so let's go ahead and do some data conversions here. All right, for instance, let's declare an integer called Bob, and it's going to be equal to 22. Let's declare a double called Roger, and that equals 3.4. Right. Now, let's say, let's print them out right now. System.out.println. We'll just print them out individually. Bob plus and plus Roger. Okay, so this will print out Bob first, put an and in between, the actual literal word and some space in front and behind it, and then it'll print out Roger. Okay, so let's see what it looks like. So we should expect 22 to be printed because it's going to go to the Bob memory area and pull out the number stored in there, concatenate the string and to it, and then concatenate whatever stored in the Roger area of memory. All right, so let's go ahead and execute that. What do we get? 22 and 3.4. Sounds good. Now, what happens if I then say Roger equals 4? Okay. Now again, you may look at that and say, "Oh yeah, sure, Roger can handle 4. Roger's such a big memory location." But remember, when Java sees 4, it thinks it's an integer because it sees no decimal point. So what happens here is it actually assigns it to Roger. This will happen. Here, I'll hit compile. Look, it's going to work just fine. Process completed. No problem. But what did it store? Let's go look. System.out.println. Roger's new value, and let's print out Roger with it. And now let's see what it actually stored in memory. So we'll compile and let's execute. 4.0 is what I got out. That right there is an example of assignment conversion. It knew that this is a double value. This is a floating point, has some decimals in it. This is an integer. Well, that's not a big deal. Decimals can be more precise. They can do a lot more numbers than integers can. So what it did is it automatically widened the 4. It went ahead and put 0.0 on it because Java knows that putting a 0.0 on the end of 4 has no effect on the value at all. So it promoted it up to a double when it assigned it. That's called assignment. Okay? Assignment conversion is going to do that. All right? By the way, you could also make Roger equal to Bob. So, again, the assignment's done last. It gets the value out of Bob. Says, Bob, what's your value? Goes into memory. Memory, blah, blah, blah. Oh, 22? That's not a big deal. 22 is now assigned to Roger. Again, Bob was an integer, so that 22 is going to be converted by assignment up to a floating point value. So right now you want to think, what number will we put right after the 22 now? New value plus Roger. Right. So have you figured it out yet? What number is going to be put right after that 22? 0.0. Because 22.0 is the same thing. But don't forget, that doesn't change Bob. Because all it did was it went to the memory location and got Bob's value. So when I look at Bob, Bob should still have the same value because we didn't do anything to it. All it did was get the number out of it, but it copied it out of it. It didn't change anything. If I want to change something in Bob, Bob needs to be starting out on this side with an assignment after it. So when I hit compile here and execute, Bob maintains the same 22 at the end. So I changed Roger throughout this program, but not Bob. So that's essentially what happens. Java has no problem widening, okay? That is not a big deal, okay? And arithmetic promotion, that also can happen all the time. Arithmetic promotion will widen things as well. So for instance, let's do some integer division real quick. So let's delete some of this stuff here. And let's make a new value called double total equals. And we're going to say, let's take Bob divided by Roger. Okay. And just to give you some concrete example, let's try donkey equals. So let's put an actual value in here so you're not thinking just in variable terms. 30 divided by 4.3. Okay? Again, think what Java sees. Java sees an integer, but it also sees a double. And it says to itself, well, I can't divide, these are two different data types. I need to have a common data type. Well, that 30 is an integer, and this is a double. I will automatically, and it's okay if I convert that up to 30.0. It'll do it for you. You don't have to worry about it. So it will go ahead and convert it up for you to a 30.0 so this division can actually occur and not actually run any errors. Because let's say I did double equals 30 divided by 4. Okay? 30 divided by 4. So you're like, well, hey, I'm setting up a double space in memory, a space for floating point in memory. 30 divided by 4. Boy, that should give me decimal places. Let's take a look at that and see what actually happens here. So let's first print out total. And let's actually be nice here. Total. And let's print out total. Let's go ahead and copy and paste this a few times since we're doing this. Bing, bing. Okay, save ourselves some typing time there. Donkey. Change this to donkey. And then change this to And this will be Right? Let's see what happens. Okay. So total is Bob divided by Roger, so it gets the value from Bob, divides Roger by it. Remember, Bob's an integer. That's a double. We expect it to go ahead and make the 22 it grabs out of Bob a 22.0 and do a normal division there. This is the same thing, just with concrete numbers. There's an integer 30, a double 4.3. It should arithmetically promote that up to 30.0 so it can do a full double division. Here, integer, integer, it's going to do integer division. And as we saw before, we should expect only an integer to come out of this. However, it's going to assign it to a double. Wonder what that's going to produce. All right, let's compile. And let's see now. So I can see that I actually get decimal values out of total. I get a decimal value out of donkey. I do get a decimal value out of however, it's just 0.0, and that's not the true answer to what you would probably get in your calculator if you did 30 divided by 4. Because 30 divided by 4 is 7, the integer 7, because these are two integers. So it comes up with 7. But then what's it do with that 7? Assigns it to a double value, and we just talked about that. Now what's going to happen is it promotes that integer 7 at the assignment time to 7.0 because it knows it's the same value. Okay, so that's an example of arithmetic promotion. Okay, it seems complicated. It's really not too bad. Okay, the last way to do it is by casting. Casting is when you want to tell Java to do it whether it likes it or not. Okay, so you can widen a value here or you can narrow a value here, and Java's not going to tell you you're wrong because it's going to say, hey, if this is the way you want it, bud, you'll get it this way. The way you cast something, casting is saying, oh, you're a double, bam, now you're an integer. Or you're an integer, bam, now you're a double. So let's say I have a value of total, which is an integer, and count, which is an integer. Except for I don't want this division to occur as an integer division. You just saw what happened to integer division. 30 divided by 4 gave me kind of an inaccurate number. So I want this division to occur as if it were a double system. So what you do in front of the integer that you want to start as a double is you type the word double in parentheses. So what it does is it takes that value total and says, okay, man, I'll make that a double for you. Not a problem. And it makes total a double. It just adds a 0.0 onto the end of it. You might say, well, why don't you make count a double? Why don't you have double there? Well, remember, that's now a double. And if that's now a double and it sees an integer here and it's two different data types, it'll widen that automatically. So count gets actually arithmetic promoted right up to the 0.0 no matter what. Because it's like, man, I can, if you're going to make that a double, I'm just going to go ahead and make that a double. And so then it assigns that into the result value. Okay? So that's called casting. You can cast values up. All right? And casting is a very, 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 very powerful thing. We're going to leave it here now. In fact, this is going to take up 2 videos doing this. I'm going to have to splice it in half, but not a big deal. I will catch you up here next time when we start talking about objects. So stick around, go ahead and work on some of your programs, and we'll talk to you next time. See you guys.